What I'm going to talk about is 3D printing, sometimes known as additive manufacturing or direct digital manufacturing. If you think it doesn't affect you or isn't going to affect you, you're wrong. It's coming in, and they're saying that in the near future we're going to see those, just like a microwave in your house. You want a new glass, you're going to be able to print a new glass. You want a coat hanger, you want something a little different size, a little different shape than you have right now. You just change the parameters on the drawing and then put it into a printer. Things you can build, they're used right now for prototyping, for dental work, hearing aids. They can actually build a hearing aid. They take a mold and a scan of your ear, they build it overnight. So it can happen real fast. Come on here. The piece on the left is part of an aircraft. On the right, they're just a piece of art. And the beauty of these is that you're actually building from the ground up. So you're not, it's additive as compared to standard machining where you're actually taking parts of the piece away with the machine. When you use this 3D printer, you're actually adding parts, or adding layers. The bottom left, this is a Wilmington robotic exoskeleton. This little girl has no strength in her arms. So they built this system, and it's all just ran by elastic bands actually. But if a part breaks, her mother just takes a picture of it, sends it to the supplier, they send her back a new piece. And as she grows, they just scale that up. They just scale the actual piece, add another, say 10% to it, and give her a whole new exoskeleton. How do we get pieces in? This is a 3D model. If you have a 3D model of any sort that has solid surfaces, so whether you're going to do a 3D model of of this piece of equipment here, or a glass, or a piece of artwork, or anything you think of. Actually, there's no reason we can't do cupcakes, or the icing on cupcakes. No reason whatsoever. Another way you can do it, if you're in the engineering side of things, you can actually reverse engineer. You can use, on the top left is a laser scanner, and the bottom is just a handheld probe. It's just got a little post on it. You just tap, and it records that actual space, or pointed space, and then use all those different points, and you rebuild the actual piece of equipment. So you can actually go in and scale. If you come into a room like this, you could actually scale this, or scan this room, and then reprint it. Print a scale model of it. Printers, like I said, they're going to be commonplace. They are commonplace now. They're coming out. There's no end of them coming out right now. The top one is a MakerBot, about $2,000. The little one in the middle with the colored plastic on it is about $1,200. And this is one that's coming out for hobbyists. And you're going to see more and more of these all the time. Top right is the one we have over at the college. It's about a $13,000 piece of kit. And then they just go up from there. There's amazing different types. There's all sorts of different types. The polyjet or inkjet printing, they actually took an old HB inkjet. That's how they started. And they just took the print head off and they injected it's a special type of polymer, and then they just dropped the table as they printed layers. What we have is, if you use deposition modeling, it's a type that just puts a layer of plastic down. And you can think of it as a glorified glue gun. That's all it is a high-tech glue gun, putting in this ABS plastic that I passed around. And then the two at the bottom are using lasers, and there's special polymers that are actually set by the laser. And the one on the right, it's sintering. So they're actually taking, and basically they're melting, whether it's glass, steel, any sort of ceramics. They actually used the sintering method in Sweden, and a woman had a degenerative problem with her jaw. So they did a CT scan of her jaw, a 3D scan, and then they made a titanium jawbone for her. This is a new system that they've got, and there's anybody in the manufacturing business, this is phenomenal. They're using a buildup of metal, and they can build aircraft parts. You can use titanium, another metal I've never heard of, tantalum, or any of the Inconels, and they're real hard metals, and they can build up parts. They can actually go up to 19 feet by 4 by 4. And so instead of, if you had a big block for an aircraft of magnesium or titanium, and you had this, you might have to start with a block that's 200 pounds to get a 5-pound block. This one you could start, and you build it up from the bottom, so you could maybe, it might take you 50 pounds of material, but it's a huge saving. And this is, like I said, this is commonplace now, especially in the aerospace. And if you think that, go on, hello. Okay. The only thing that limits you on this is your imagination. Right now, the bottom left is a lunar crawler or lunar rover that NASA is building. It has parts that are built with these 3D printers. And this other shot is actually the European Space Agency's idea for shelters on the moon. The Russians are using it, or have got a plan to use it, and so do the Americans. Basically, they take a 3D printer up and they use moon dust. And I'm not sure what process they're going to use, but they actually can make these shelters. So I challenge you, if you can think of something, it's probably, you could make it. They're actually printing people's or replacement organs right now too. They've got kidneys that they've been able to reprint or print. They're still in the animal testing phase, but it's coming. So it's going to happen. Why did my phone? Oh, that's my timer. So like I said, if you think it's not going to affect you, you're wrong, because they're coming, and they're going to be commonplace in very short order.